Hey guys, we're going to be studying forms of energy in this lesson, and we'll cover potential energy and kinetic energy specifically. We have a bookwork associated with the lesson, you'll find it here. Please just list this heading at the top of your classwork page and write down this aim. How is energy stored and converted to other forms? Um, you can do a sketch of this diagram in your Do Now, but obviously it doesn't need to be an artistic masterpiece. But if you capture the essence of it with words, a word diagram, that would be fine. And here's the question, what concept is illustrated? Okay, so forms of energy. Um, Energy, as you know, is the ability to do work, and that is the only definition for it. So it also means that energy has like a wide range of forms. Among those forms are kinetic energy and potential energy, but we also have thermal, electrical, chemical, and nuclear, and that's not even a complete list. So, just as an introduction, internal energy is a type of energy that is really just the energy of the individual molecules that are in motion inside a substance, such as a glass of water. Their motion is internal energy. They also have energy stored in the distance between the molecules as well. We have nuclear energy, which is the energy that comes from doing fusion reactions and fission reactions, and it relies on a concept called the mass defect, which is just a term that means that matter is converted into energy. Electromagnetic energy is one that we rely on a lot, and it just takes the electrical energy that is produced by moving a magnet through a magnetic field, and we use it to make all of our electricity actually. We have a whole range of devices that are used to convert one form of energy to another. For instance, we have motors and generators, which do sort of opposite things. A motor would take electrical energy and turn it into mechanical energy, whereas a generator takes mechanical energy and forms electrical energy. You can study the rest of this diagram yourself, but it's just a starter to think about the machines that we use to convert one form of energy to another form of energy. I found just a few examples of diagrams for these machines. One example of a generator it converts gravitational potential energy into electricity using a hydroelectric dam. And then we have our just typical batteries that convert electrical energy into light energy, and in this case, and we have motors, electrical motors that turn electrical energy into mechanical energy. And here we have a photocell, which converts light energy into electrical energy. So any kind of solar panel would use light energy to convert to electricity. So the two that we are going to go into just a little bit more detail and do just a little bit of math on are potential energy and kinetic energy. So potential energy is here. Gravitational potential energy is just the energy that's stored in the distance between the ground level and some object that has mass. So because of the gravitational force of attraction between those two objects, the more height there is, or the more separation there is between the ground and the object, the more gravitational potential energy there would be. So in short, I'm saying that there's a direct relationship between the potential energy of an object and its mass or its height above the ground. All right, so here's our equation for it. It just says that the difference in potential energy from one place to another place vertically distant from that one is going to be the mass of the object multiplied by the gravitational field strength of the planet, and the change in height, the distance between the ground and the object whose potential energy you're describing. So units are typical. The mass is kilograms, gravitational field strength is in meters per second squared, and the change in height would be measured in meters. But that's pretty much it. The equation's not so complicated. Let's do an example. calculate the gravitational potential energy, so that would be measured in joules, with respect to the floor gained by a 2 kilogram object as a result of being lifted from the floor to the top of a 0.92 meter high table. So we're looking for potential energy, so I'll just put that here. And we have a mass, and we are going to assume we're on planet Earth, so we have a g, which is 9.81, and the 0.92 meter table is a height. So here's my equation. Change in PE is mg delta h, and we are looking for the change in PE, so there's no need to rearrange here. And the mass was 2 kilograms. Gravitational field strength on Earth is 9.81, and the change in height would be 0.92 meters in this case. I just ran the calculation, and I got 18.05, which with significant figures could just be 18. So 18 joules is my final answer. Here's another example. A 15.3 Newton book, so this is a force of gravity. It gains 18.4 joules of gravitational potential energy. With respect to the floor as a result of being lifted from the floor to a shelf, calculate the height of the shelf, and let's assume that we're on planet Earth, so we have g. So the change in potential energy is described by mass, gravity, and change in height. We are looking for the change in height, so divide both sides by mg, which cancels on the right, and the change in height would be the potential energy change over mass and gravity. The potential energy change is 18.4 joules, and the mass is not 15.3 newtons. The mass is going to be that divided by 9.81. However, I noticed that my equation has mg in the bottom, and Fg is mg, you might remember. So what I'm going to do is, instead of taking this number, dividing it by 9.81 to get a mass, and then multiplying it by 9.81 because that's what the equation says, I'm just going to take this value and put it in here, 15.3. And the value I get for that is 1.20 meters. Okay. Kinetic energy really goes with potential energy all the time, but it's also a different idea. So kinetic energy is the energy of motion rather than the energy of position. That's what potential energy was. So the energy of motion, of course, would need to have like some variables in it that describe motion. So velocity is one that you would probably guess anyway, but kinetic energy is going to be 1/2 of the product of mass and velocity squared. So this is going to be a direct squared relationship between the kinetic energy and the velocity of the object. But between the kinetic energy and the mass, it's simply a direct relationship. So that's pretty much the equation. Let's do some practice on the next slide. Let's calculate the kinetic energy possessed by a 2.7 kilogram cart traveling at 1.5 meters per second. So kinetic energy is 1/2 mv squared, and we're looking for kinetic energy, so there's no rearrangement necessary. You do need to multiply the product by 1/2, but the mass is 2.7, and the velocity is 1.5. We will need to square that velocity. And I just ran the calculation, and I got 3.03 joules. With significant figures, I would really only need to keep 2 of those digits, so my final answer would be 3.0 joules. And with that, we have reached our pair-up, so I will have these copied for you. You don't need to copy these down, but you can glance at them, you can think about them. Here's some more pair-up. And I do want you to copy down this summary, however. So on your classwork page that's separate from your notes, please just have the bookwork assignment listed, followed by the do now word diagram or pictures if you're being amazing, and then basically just follow it up with the summary, these summary questions. We'll answer these in class next time I see you. And thanks for watching, and have a great evening.